This video is the next in our series from Ty Brannaman. He came out to our apprenticeship program and taught about electrical basics. So in this video, he covers transformers, induction, as well as some common electrical issues. If you haven't already done so, please go down into the description, click the link to Ty's channel, and subscribe and view his videos. They really are excellent. Big thanks to Ty for giving this class at Lake Technical College in Eustis, Florida.
Now, earlier today, Brian was talking about electromagnets, coils, and transformers. We're going to continue to talk about transformers, and actually today we're talking about transformers. The number of wraps between one to another, you have a ratio between one side to the other. So here, I have my transformer, and its job is to reduce the voltage, but it doesn't know anything. It's just wraps of wire. Now look. You see how this wire is wrapped around right here? Do you guys see that? Mm-hmm. And there's another set of coil wrapped below it.
It's got less wraps. If it's a step down transformer, it's got less wraps in the bottom.
That's exactly right. Good, good. Now look here where wires are coming out of one side and the other wires are going on the other side. Did you guys know that the wires from the primary power in do not actually touch the wires coming out of the secondary coming out? They don't touch. They don't touch at all. Did you guys know that? No. This is what's cool about electricity. Remember we talked about electricity and magnetism? So if I send electricity through a coil of wire, my primary is a coil of wire. If I send electricity through this coil of wire, what's happening? What am I creating?
Electromagnet.
Electromagnet, yes! Electromagnet. I'm creating an electromagnet. Now what's that electromagnet doing to this iron core right here? Anybody know? Magnetizing it. It's magnetizing it. It's magnetizing. That's alternating current, so it's north-south, north-south, north-south. But it's energizing this magnetic field. My magnetic field is essentially moving back and forth 60 times a second. I can't move my finger that fast. Follow me? Now, what happens when I send a magnet through a coil of wire?
You make electricity.
I make electricity, so to speak. So here's what's happening. My second coil of wire, I'm actually pushing a magnetic field through the coil of wire. Oh, this guy nodded. You got it.
That's pretty cool.
No? Oh, you're killing me. So if I have the primary and I'm pushing electricity through it, I'm actually creating a magnetic field. The secondary, I'm pushing a magnet through a coil of wire. So what's it doing?
Magnetic.
Creating
Electromagnet.
So I'm using that magnetic field to create electricity. Now the number of wraps tell me how strong my field is going in versus how many wraps I have, how strong I'm picking up coming out. What happened if I had the same number of wraps on one side and the same number of wraps on the other side?
You're going to have the same electricity.
The same voltage. Would we ever do that? The same number of wraps on one side, the same number of wraps on another.
Contactor.
No, for nothing.
No, I like your answer, but that's not what I'm looking for. What?
We'll
Nothing?
do it for nothing. Well,
What do you think? Would we ever have the same number, 240 in and 240 out?
whatever I say is wrong.
No, I don't care that it's wrong. I love the fact you're participating. I don't care that you're. I love that you're answering. That's what I like.
I can't think of anything.
Okay, good. I like that. That's a good answer. That's a good answer. What do you think?
Well, why would you need it if you're going to get 240 out here? Why would you even need it?
I love it. Why would you even need it? Why would you even need it? Why would you even need it?
Oh, that's what I was like, I don't think they make that.
I don't even think they make that. Bert, do they make that?
I'm going to go with yes.
Yes is the answer. Yes. It's called an isolation transformer, and it actually works very well at cleaning power out, right? If you have surges, if you have different types of bad power or bad sine waves in there, it works really well at smoothing out or cleaning that power out. You'll see sometimes amplifiers or musical instrument stuff will have isolation transformers for the power in so they don't contaminate the music or the other sounds. There's many times that we'll actually use isolation transformers. Fairly rare that we'll see them in HVAC, but it is. Now what's more important is stepping it down. Do we ever step it down?
Yes.
Yes, here we're stepping it down to a lower voltage. Now do we ever step it up in HVAC? Would we ever need to?
Not in HVAC.
Not in HVAC, everybody agree? Would you step it up? Is that ever a thing?
I haven't seen it.
You haven't seen it? Have you seen it? Seen it? No, no. Bert, have you ever seen it where you step it up? You can? You say yes? Where would you step it up?
I would step it up in an electronic air cleaner.
Oh, electronic air cleaner. That wasn't where I was going. I'm caught off guard. Yes, that's exactly right. You would increase the voltage, have it jump, zap the air, create some ozone. Yes, that's one option.
I've seen it in automobiles.
What about with a, yes, you definitely have some in automobiles. The coil Creates high voltage to make the spark jump to ignite the gas fuel mixture. Not in a diesel though, but yes. What about a gas furnace? Would you ever need one in a gas furnace?
I'm going to go yes.
Yes, because you knew how I'm questioning.
You have
I'm
to
wording the
spark it.
question. Yes, in a gas furnace because we need 10,000 volts. Can you get 10,000 volts from 24 volts?
How could you have so many?
How can you have so many? They're not even sharing.
Okay, I have a question. Because you get from, let's say, from the city, you get whatever voltage they give you, 110, 120.
Yes.
So, and if you use a step-up transformer, do you get free power? Like you getting more?
I love it. That's where I'm going with this. That's exactly where we're going with this. So, and a gas furnace, we set it up to 10,000 volts. Also, if you see neon lights, it's set up to 10,000, even higher than that. But you step it up to a very high voltage to make the electricity jump or arc. Sometimes you have a spark igniter and you're igniting the gas fuel mixture with that spark to make it ignite. But do you get free power? Now, what is the formula for watts?
Voltage times amperage.
Voltage times what?
Amperage.
Amperage. Volts times amps equals
Watts.
watts. Volts times amps equals watts. Is that important?
Yes.
Cool. Let's do a little experiment. What do you guys think? Want to do an experiment?
Sure.
Let's plug this guy in and let's calculate how many watts of power we have on this coil. So take the meter, set it for volts. Let's find out how many volts we have on our electrical load right here. All right, check right there and right there. How many volts we have?
26.
26. Everybody got 26?
Yes.
We got 26 volts. Now, I don't know if we're going to be able to read the amps. It's going to be a very small amount, but let's clamp it around here and let's read the amps. What amps do we have here?
1.
1.1? Do we have that whiteboard where we can write this down? So how many watts are we using here?
1.1.
1.1 amps, wouldn't it?
Yes.
How many volts?
26. 26.
Was it 26? So how many watts?
28.6.
28.6. 28.6 watts.
Oh, watts.
Amperage is
1.1.
1.1.
1.1.
Close enough. 1.1 amps. And our voltage? How many volts we got?
26.
26. So what's 26 volts times 1.1 amps is how many watts? Haters know.
26.
28.6. Let's write that down. 28.6. That's how many watts of power. Now let's do something else. Let's find out how many watts of power is coming into this. We're going to need to use this guy now because it's going to be a little tricky. So let's check our voltage coming in. Check the voltage.
122.
122. This is such a small amount of amperage. If you clamp it here, you're probably not going to show anything. So let's just clamp it so we can see it. And what are you showing? You're like
0.23.
Let's clamp it on this one that says times 10. We'll get a more accurate number here. What do you got?
2.4.
2.4. We're going to move the decimal over one spot. So 0.24. So 0.24 amps. How many watts do we got?
29.28.
29.28. Now we rounded a little bit, right? But notice we have the same amount of wattage going in and the same amount of wattage coming out. Wattage is electrical energy. Did I lose any wattage? No, I did not. I didn't lose any wattage. The power coming in and the power coming out is the same. What did change though?
The voltage.
Voltage and the amperage. How many amps do we have coming into this?
1.1.
1.1. How many amps do we have on the other side?
0.24.
0.24. Which had a faster amp flow?
Amps going in.
The lower voltage had a faster amp flow.
We had more amp flow on the low voltage side. Now notice I have a transformer. Notice that I don't have a fuse on this side and I only have a fuse on this side. I have this 3 amp fuse on here. I put the fuse on the low voltage side because even though I dropped my voltage down, what happened to my amperage?
Goes up.
It goes up. So I'm going to have faster amp flow on this side. This is where I put my fuse at. I saw a guy once that put his fuse on this side. By the time I got 3 amps on this side, what do you think my wattage would do? It would go up. What would happen to my amperage on the other side?
Go up.
It'd go up even more. Let's do some math. You guys don't be afraid of math. Let's do some math. Let's assume, just draw you a line here. Let's do some assumptions. Let's assume that I had 3 amps coming in. So 3 amps coming in times our same voltage. Oh, sorry, we're on this side. 3 amps coming in, our same voltage of 122. So if I put my fuse on this side, 3 amps, and we had 122 volts, how many watts would that be?
366.
How much?
366.
366. Woo! That's a lot of watts. So write down 366 so we know. 366. Now let's do the math on the other side. We know that our 24, our low voltage would be the same, so let's keep it at 26 volts. So we had 366 watts. So put 366 in your calculator because our watts are going to be the same. Whatever watts comes in is watts coming out. Now divide that by our volts of 26. So write down 14.07. So if I had a short on this side and my fuse is on this side, it'd have to be 3 amps before this fuse would blow. How many amps are going on this side?
366.
14.7. So to have 3 amps on the high voltage side, that would mean I would have 14 amps on the low voltage side. Everything would already be on fire. This is why we put that 3 amp fuse on the low voltage side. I had a friend of mine, he's like, Ty, I'm really struggling with electricity. I don't understand why I'm using 3 amps on this low voltage stuff. That's a lot of amperage. Amperage is electricity. I need to reduce the amps on my low voltage side. It's like, whoa, 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 whoa. Just because it's 3 amps over here, does that mean it's a lot of power?
No.
No. Our wattage was only, what, 29? 28, 29? Very small amount of wattage. So don't get hung up in thinking just because I increase voltage or decrease voltage that I'm changing the power. What is the formula for power?
Volts times amperage.
Volts times amps. That's watts, that's electrical power. The same power in is the same power out. So if you asked, would we get free power? If I was to increase it to 10,000 volts, how many amps would it be? You don't have to do the math right now, but a very small amount, right? A very small amount. If I increase the voltage a whole lot, what does my amperage do?
Goes down.
Goes way down. I would have very little amperage. So here's what's cool. Your transformers will have a rating. It's called a VA rating. V for volts, A for amps. What happens when you have 2 numbers side by side and a formula with a dot in the middle? Means multiply. So what if I have V right next to A? Would that be a mathematical equation?
Mm-hmm.
Yes, volt amps. So if I multiplied volts times amps, what would I get?
Watts.
Yes, watts. It's watts, right? So transformers have a VA rating, aka watt rating. And the watt rating would be 45 or 75 VA. And when you're changing out a transformer, it's important to know that number because if it's only rated for 45 watts, and all of your low voltage loads you need 75 watts, is it going to be built strong enough?
Mm-mm.
No, you're going to have problems. Sometimes you may say you may add some low voltage circuits to the unit. You got to make sure your transformer can handle the watts or the VA of that unit. So VA, volt amp, so this one's worn off. I've had it for so long, you can't see it anymore. But it's a very low volt amp rating. In my truck, I only kept, I think it was 75 VA transformers because a 75 VA transformer will handle 75 VA loads and also 45 VA loads. Just because it will handle 75 watts doesn't mean I have to flow 75 watts through it. Moral of the story is, it takes high voltage, steps it down to low voltage. Your amperage does not mean power and your voltage does not mean power. If you're replacing a transformer, it's important to match up your voltage coming in and your VA, okay? It's an electromagnet, inductive load. I'm inducing electromagnetic field, and that electromagnetic field is being induced into the secondary coil. So who was it that asked about low voltage circuitry? Was it you? Okay, so does that help a little bit? So don't be afraid of the volts and the amps. You need to be thinking, I'm going to have this is my new source. I'm starting out with approximately 24 volts here. I'm going to go into a switch, out of a switch, into my load, out of my load, home to the opposite side.
If I have a call where a transformer has blown up,
Good, yes.
and I put another transformer in, how can I figure out if I'm going to blow up the next transformer?
It's a great question, but let's back up a little bit. If a transformer blows out, why did it blow out?
You have too much
Too much voltage.
volts.
Ooh. Amperage, the speed of electron flow, that's what's going to burn it out. So if I have a transformer and it goes bad and I got to replace it, that means my amps are flowing too fast. Is there any kind of device that I can put on that protects my amp flow?
A fuse.
A fuse, bam, right here. Now this goes to the first thing is never replace a transformer without adding a fuse. Just never. Now you can buy these fancy fuse holders, but look at this. This is really cool. You get 2 of these connectors, and every technicians that have these in their truck of one kind or another, and it's cool because the fuse will just slide in. There's no reason to not have a fuse. You can just simply slide it in. Now you can tape these, you can do all kinds of other things, but bam, I've added a fuse that easy. So there's no reason we can't add a fuse. Every single transformer should have a fuse. So if you're blowing a transformer, you should first, hey, let's put a fuse in, because if we pop fuses, they're a lot cheaper than popping transformers, and it's a lot easier to replace the fuse in a transformer. But then what do we got to do?
Figure out the problem.
Yes! Figure out what blew it. Something killed this guy. It didn't just like, you know what, I've had enough with my low voltage life, I'm done. No, somebody came and said, I don't like you anymore. Boom, took him out. Something killed it. Your job is to find the murderer. What killed this guy? So you put a new one in, you want to protect him. This is his protection. They're going to watch him 24/7 to make sure he's safe. You're going to find out what killed this guy. Now, what killed it is going to be either a short to ground, like a wire rubbing through a cabinet, the wires inside the condenser. Look over here in this condenser. Do you see any wires in there at all? This one's even better. Look at this one. Look inside. Do you see any wires in there?
The compressor.
Compressor wires. There's a high pressure switch, a low pressure switch. There's a solenoid for reversing valves. There's all kinds of wires in there. What happens if those wires rub against one of those pipes?
It's gonna melt the insulation, or
It's going to eventually
or
rub
worn
the
it-
insulation
worn
off
it
the
out.
copper. It's going to be a direct short from that to the copper, or it'll even rub a hole in the copper. We went through, I think, 4 calls in this week that we had issues with rubbing where the wire rubbed out in maintenance. We ended up having to seal up that wire and make sure the wire wouldn't rub against the copper. If you're looking for a short, you're going to be checking those low voltage wires inside the unit, outside the unit. Notice how these wires are exposed. Look at this. Look how somebody burned it. That's a prime example. Somebody used a grommet right here to make sure it doesn't rub. But I've seen tons of times where this wire rubs into the metal. Let's see where it goes on the other side. If it goes over here, we go around the top, we come in the top here. Let's feel where this wire comes in. Is there anything for it to rub on? I'm vertically challenged. Is there a grommet?
Yep, that's a
Good. But look at this little knockout right here. You guys see this little knockout? A lot of techs, you'll see this little knockout. What they'll do is they'll knock that out and they'll run their low voltage wire through there. Now that wire is rub it against. Now you give it a short path. Electricity can flow from that low voltage wire to the metal. Boom, shorts out. That's an example. So shorts, you're looking for anything like that. Also, stripping this low voltage wire. Do we have a piece of low voltage wire, a little thermostat wire and a wire stripper? When people strip thermostat wire, they notoriously do this. We have some with the outer coating on it still. This is what a lot of people do. They'll do this right here. They'll take the wire like this, strip the outer, and then they do this. Well, what they don't see is what's happening right here. So we're going to pull this out. Now look at all those little nicks I left on there. This happens a lot. People will strip wire like that, and these nicks will end up touching each other, and that will short it out. Here's how I like to strip wire. Right, you grab this wire, preferably the string actually is what you're supposed to do. We'll do it proper. We pull that wire back, but here's what else I like to do. I like to take this tailings and I like to bend it back over itself. Look at that, isn't that pretty? Now I know for sure the next guy coming behind me knows that it wasn't stripped. And now I'm gonna cut this tail out of the way because I don't hate that when the tail is left there. Now look at that. I know that there's no short right there. I know it's clean and pure and ready to go. Now I can cut all these nicks off and strip them individually. But that's a huge issue where people do that right there. They take and they cut this and they do it like right here. Nope, that was actually done fairly nice. That was good. So, but they'll short right there. And the next thing you'll have is a contactor that's shorted out. The coil, like we had this one that was burned up, it burns out, the resistive is too low. So if you're having a short in a low voltage side, it blew a transformer, you're gonna put a fuse, you're gonna find it. You're gonna inspect all of these little locations, all these spots, where it goes through metal. And then you can ohm out all your low voltage loads. You can ohm out the reversing valve. You can ohm out the contact. You can ohm these out. Let's say you don't know what your contactor should be. Go to the truck, grab a new one. Hey, let me check it. Oh, well, look, I'm getting 10 ohms there. I'm getting only 3 here. Those contactors are pulled in. There's a lot of heat right there. It's a very thin wire. You lose the insulation on it pretty rapidly. So if you're having an issue when your contactor blew, find out why. Now here's the thing. You'll put a new contactor on. Oh, I couldn't find it. There's always somebody working that says, oh, Ty, yeah, I couldn't find it. And they know not to tell me that because I will jump down their throat and be like, no, you go back and you find it. Here's what happens. Sometimes it only does it in windy days when the wind's rubbing and pushing against it. Sometimes it's only when there's a lot of humidity in the air and it actually caused the short. Or sometimes only when it rains. Just because you couldn't find it today doesn't mean it's not there. Just because you couldn't find the murderer doesn't mean one doesn't exist. So you find it, you stay and you find it, or you come back on a callback for free on your own time and find it on a Saturday night at 3 in the morning. It will be there. You find it then or later. But don't be afraid. Take your time. Go through. Follow the circuits. Follow the wires. Go through and follow everywhere it goes, and eventually you will find it. And the more that you do it, the more experience you have, the easier it comes. You start finding common spots. Hey, I know where the shorts hang out. They like to hang out where this guy cuts the wire. That's where the shorts hang out. I'm going to go look there first. I'm going to go look in that condensing unit where carrier runs that wire right up against that suction line and it vibrates and rubs against it. I know that's a bad place to leave short. I'm going to go check that out. We're going to go see what's happening in there, right? There's common places you start to look for. Sometimes there's companies. You know, hey, this company, I know they installed it. I'm going to go ahead and look for this short before it even happens. It's going to be right here. These are things you get used to seeing.
Thank you, Ty, for giving this class. Click the link down in the description in order to find and subscribe to his channel, and we'll catch you on the next video. Thanks for watching our video. If you enjoyed it and got something out of it, if you wouldn't mind hitting the thumbs up button to like the video, subscribe to the channel, and click the notifications bell to be notified when new videos come out. HVAC School is far more than a YouTube channel. You can find out more by going to hvacrschool.com, which is our website and hub for all of our content, including tech tips, videos, podcasts, and so much more. You can also subscribe to the podcast on any podcast app of your choosing. You can also join our Facebook group if you want to weigh in on the conversation yourself. Thanks again for watching.